Okay, hi guys. I know I'm going to say this a lot this year, but I think the Pythagorean theorem is one of my most favorite theorems in mathematics. I'm not sure why, but I love using the Pythagorean theorem. The history of Pythagoras, there's a really good history there, and we're going to take a look at the history of Pythagoras and the Pythagorean theorem tomorrow. But today we're just going to go over the nuts and bolts, and it should be a review from last year. And if you can't remember which side is the hypotenuse, you can look at this hypotenuse right here. He is laying on the hypotenuse. Okay, in a right triangle, the side opposite the right angle, which is this side right here, it's the opposite the right angle, and it's the longest side, is called the hypotenuse. And it's hippo, and then 10, and then use. It's the longest side, and that's important to remember. Each of the sides forming the right angle is called a leg. And we have leg A, and we have leg B. So we can use a theorem called the Pythagorean theorem to describe the relationship of the lengths of the sides of the right triangle. And we'll take a look at that Pythagorean theorem in depth tomorrow, but that is called the Pythagorean theorem. And actually, Pythagoras, who was a Greek mathematician, did not discover this theorem. He actually traveled to Egypt, stole it from the Egyptians because that's what they used to build the pyramids, and then he stuck his name on it. So the Pythagorean theorem says that if I square the legs and I add them, that's going to be equal to the square of the hypotenuse. And that's what this theorem says over here. In any right triangle, it has to be a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the hypotenuse. So let's take a look at what that means. We need to find the length of the third side of a right triangle, give an exact answer and an approximation to 3 decimal places. So we're going to look at this right triangle right here. We have A, we have B, and we're missing C. So we're just going to write the Pythagorean theorem, A squared plus B squared equals C squared. I'm going to let this leg equal A and this leg equal B. And how do I know they're the legs? Because they form the right triangle. So I'm going to substitute in 4 for A, 3 for B, square them, add them, and so 25 equals C squared. The last step of every Pythagorean theorem problem is to square root both sides of your equation. If I take the square root of 25, that's 5, and the square root of C squared, these cancel, a square root cancels a squaring, is C. So the length of the hypotenuse is 5. And anytime you're missing the hypotenuse, you just square the legs, add them, and then take the square root. If you have the hypotenuse, but you're missing a leg, it's pretty similar. And this number right here should be an 18 because it's impossible for this number to be a 1. Because if this is the longest side, it has to be bigger than this side and this side. So we know that the hypotenuse is 18, and one leg is 6, and the other leg is missing. So again, we're going to write down the Pythagorean theorem, A squared plus B squared equals C squared. I know that A is 6. I don't know what B is, and I know that C is 18. 6 squared is 36. 18 squared is 324. Now I need to subtract 36 from each side to solve for isolate the variable. They're going to cancel, and I get B squared equals 288. The last step of every single Pythagorean theorem problem is to square root both sides of the equation. A square root cancels a squaring, And the square root of 288, rounded to 3 decimal places, is 16 and 971 thousandths. And you can plug that back into the calculator. If you do 6 squared plus 16.971 squared, it should come really close to 18 squared. Okay, in examples 3 and 4, in a right triangle, find the length of the side not given. Give an exact answer and approximation to 3 decimal places. This is what we just did up there. A squared plus b squared equals c squared. So 3 squared plus 16 squared equals c squared. Nope, not 16. I squared it in my head. Plus 4 squared equals c squared. 9 plus 16 equals c squared. 25 equals c squared. And again, last step is to take the square root. And we get 5 equals c. So the hypotenuse length is 5. And these guys right here, this 3, 4, 5 is what we call Pythagorean triple. And any multiple of that, you know, will work. So if you see legs of 3 and 4, the hypotenuse is always going to be 5. We can do 6, 8, and 10. We can do 9, 12, and 15. Those are what we call Pythagorean triples. It's where all of the legs, or both of the legs, and the hypotenuse comes out to be integers. So go ahead and try number 4. Pause the video and then check your answer. And number 4, we are missing a leg. That's what we're missing. So Pythagorean theorem, a squared plus b squared equals c squared. Plug in what we know. Square what we have. 15 squared is 225. 17 squared is 289. Subtract 225 to isolate the variable. B squared equals 64. The last step is to square root. And we get b equals 8. So there's another nice Pythagorean triple, 15, 8, and 17. Okay, there's one last type of problem I want to show you that's not on these notes, but I would like you to write it down in the notes. It's when you're given 3 sides and you have to determine, 3 sides of a right triangle, you have to determine if the following measurements will form a right triangle. So we're going to call this example 5. Determine if the following measurements will form a right triangle. And this is what we call the converse of the Pythagorean theorem. We use the Pythagorean theorem to find the missing side, but when we have 3 sides, we use the converse to tell us, hey, is this will this make a right triangle? So which one is the hypotenuse? Well, I said before the hypotenuse has to be the longest side, so we're going to let 6 equal A, 8 equal B, and 10 equal C. So the Pythagorean theorem, plug in what we know, does 6 squared plus 8 squared equal 100 squared. So 36 plus 64, no, not 100 squared. Sorry, doing it again in my head. 10 squared. So does 36 plus 64 equal 100? And yes, it does. And how do we know that? Because the sum of the squares of the legs equals the square of the hypotenuse. Once again, it's your turn to show what you know from the notes. So in number 1, you're solving for B, you're solving for a missing leg. And number 2, you're also solving for a missing leg. What is the length of A if B equals 6 and C equals 10? Be sure to work out the problems in your homework notebook and go onto the Google form and submit your answers. Have a good night.